like and leave a heart, please.
There we go. Hello, everybody, and welcome to the Vidor Locksmith Show. I'm your host, David Gibson. Oh, what a wonderful, wonderful, wonderful show. So happy to be here with you guys on this Friday. So we are unlocking the secrets to success in the oil and gas industry. One interview, one technical presentation, and one technical screw-up at a time. Please let me know what the technical screw-up for the day is. If we do run into one, I shouldn't say if. I know we're going to. Just let me know what it is in the comment section. We'll get it taken care of as quick as we can. All right, guys, please let me know where you guys are watching from. Love to be able to give you guys a shout out here on the show. As well as just a request this Friday, if you would, as the show's going through, tag somebody in the comment section who you think would get something valuable out of the show. Love to be able to spread the love and let more and more people know about the show and what we're doing here. So, all right, let's see. I think we've got at least a couple of comments already started to come in. So, Eric, as usual, says hello from sunny south of France. Eric, once again, thank you for being here. One of the true loyalists here to the show. Michael, tuning in, says good evening from Abu Dhabi. Ramadan Kareem. All right. Well, we've got a couple of people already tuning in. So just in case you guys were wondering, we have done absolutely amazing job here on the show, and we have got ourselves a sponsor once again, just like last week. This week, brought to you by #Rig Reports. And this week, once again, we're going to be giving away another one of these. So yours won't say David Gibson on it. I mean, unless you want it to for whatever reason, but have your name on there. And then we've also got rigreports.com right there in the back. Those guys are absolutely amazing. So we'll be giving away one of these. All you got to do is put in #RigReports during the show today. And then as well, of course, we'll also be sending you out one of the Gibson Reports 3D printed drill bits, sending one over those to you guys. All you got to do, I almost dropped that on the floor. It's already broken, so I've done it once before, so almost did it again. Right, so anytime from now till the end of the show, put in #RigReports. We'll get you guys entered for a chance to win. We'll do that towards the end of the show. Obviously, there is Salal from Rig Reports. Thanks for being here. Him and I are working on a I won't say it's a very top secret project, but it's a top secret project right now. We've got some really interesting things coming up for you guys in the near future. So be sure to stay tuned to that. Oh, as somebody we all know, Mr. John DeWart tuning in from Elkhart Lake, Wisconsin. Spring is emerging. That it is, sir. See, he's already putting in #Rig Reports. All right. John tuning in from San Antonio. Thanks for being here. Mr. John Weatherly tuning in from Austin. Love to be able to see it. Eric's getting in on the #Rig Reports. There we go. Borna tuning in from Stavanger. I will be there next week. For anybody that is going to Norway next week, let me know. There we go. Mr. John Weatherly putting in #Rig Reports. And then Abinash, good morning from Houston. Love to see him tuning in and being here on the show. It's one of my race team buddies. All right. And Mustafa putting in #Rig Reports. All right. Everybody's getting in with it. So, like I said, you guys could win one of these fun little things. I don't even know what to call it, but it is cool. Have your name on it. Vidor Locksmith. And drill bit. All right. That is the intro portion of the show. All right. So, got to pay some bills. We'll do a quick little commercial, and we'll be right back with today's guest. All right. Let me find. There it is. All right. All right, guys. Oh, yep. All right, I've got to tell you guys about Rig Reports from Mi4. They are sponsoring the show, and Rig Reports is their daily operations app for operators and consultants. It is a very impressive system. Imagine this. You no longer are stuck messing with Excel, email, or paper reports. Everything is digital and automated, so it's more accurate and efficient. You get real-time data access to reports and analytics, which means you can make decisions immediately. It will save you time when doing things like look backs or approving invoices that come in months after the job. It's also so user-friendly. Most people figure out how to use it without training. That's a big plus. And for consultants, you'll have all your clients set up with their own databases, and you can switch between them seamlessly. So if you're still sending reports manually or using outdated and complicated software, this might be just what you need. Check out rigreports.com to learn more and schedule a demo. Trust me, it's worth checking out. And here are some of the other amazing screenshots from the system. Actually, a very, very simple system to use. As you can see here, been designed with a user in mind for simple flow, easy to use user interface and user experience, right? And as we're going through, be sure to put in hashtag rig reports for your chance to be able to enter. There you go, from the guy himself, custom desk platform. That's what it's called, a custom desk platform. Okay. All right, guys. Thank you so much. We do appreciate the guys over at, where did it go? We do appreciate the guys over at Mi4 and hashtag rig reports. So be sure to put that in and we'll get you guys entered for your chance to win that bad boy. All right. Custom desk platform. All right. Let's get on with the show today. All right. Without further ado, somebody who I have been paying attention to, seen at a lot of the IDC events. His name's been thrown around the industry in regards to drilling automation and drilling efficiency, drilling performance. Mr. Robert Van Kuilenburg. Robert, thank you so much for being on the show today. Really do appreciate having you here.
Good morning. Nice to be here. And I've been watching the shows for the last week, quite a number of them. So it's quite an esteemed number of people that went on the show.
Any favorite episodes there that you were able to watch that you enjoyed?
The one with Paul Pastusek was nice. Just a guy having a lot of fun showing all the simulations and all that. And I think it was hard to contain him diving deep into the real details of what he was doing. So it's always good to see somebody in his phase of a career that is still so enthusiastic about what he's doing.
It is fun to be able to see people when they're extremely passionate about what they do, and it's great when it happens to be drilling. So just aligns with the show. So how many episodes did you get to watch? Because if you watched them all, then I don't think you got any work done this past week.
I watched about 5 or 6 of them, and but it was interesting, and I would say it's a really good initiative, also for safeguarding the knowledge, keeping the knowledge, and in a but lighter tone than, for example, the SPE has some live chats as well, and some history of that. But yeah, it's good. People can look at it, students can look at it, says who was doing what in the industry, and it gives a face to our industry.
Well, I appreciate that, and it's what we've tried to be able to accomplish with the show is to be able to put some of the people like yourself on a higher platform and be able to get your message out there and make sure that it stays free, so that people aren't having to pay for the exchange of knowledge and information that we so desperately need. So with that, then we'll jump into the show. So Robert, for those that don't know who you are, could you give us a quick background on who you are?
Well, I graduated at the Technical University of Delft in 1996, and that's for my kids that is ancient history, of course. On the subject of neural networks, AI, and I must say my kids were also very surprised that their really boring dad did something way back when that is really relevant today. So I never thought in my life, by the way, that the subject I graduated on would be so mainstream right now. I thought, okay, fine, that's a little niche play, and let's move on. So I joined a small engineering company. Actually, it's a bit of a fun story. I also applied at Schlumberger, and I thought it would be better for me to join a small engineering company, have some fun, and develop new stuff. So I called Schlumberger and said, "Well, I'm not taking your offer," and they didn't have a tick box for that. They were so used that everybody they sent a job offer would expect. And the lady says, "You cannot do that. We already booked you everything. That you have to come." I said, "Well, I ain't coming. Sorry." So they were really surprised by that. But so I had 4 years in a company that still exists, that lives of basically inventions, and that's the perfect start for any young engineer. A director that says, "I have a cool idea, make it happen, and tell me when it's done." So yeah, that was a really great start. Then I moved back to the university to look at how people learn with simulators, in more specifically engine room simulators. Interesting topic, for basically a maritime school. Unfortunately, and people who know me, that is, if it's the truth, I tell the truth. And my conclusion was, halfway during the project, your multi-million-dollar simulator can be replaced by some desktop computers just as easily. That's not what they wanted to hear. So that was a very quick end to that. But you see the same happening right now, by the way. And then I joined Huisman Equipment, which is also for younger engineers is a really great company to work with. It's very focused on technology, making things happen, fixing challenges, lifting Russian submarines from the bottom of the sea and digging for gold there. That was also a very interesting project. I never knew there was so many shipwrecks there that contains a lot of valuables, and nobody knows how to reach them at the moment. And then I joined Noble. And Noble said, "You're a good guy. How do you like Korea?" So I joined Noble. Within 2 weeks, we were waking up in the nice Korean sun, and spent some great years there building rigs, and then went back to Houston, and basically helped Mr. Hans Doel with his R&D efforts for Noble. Engineering manager after that, and right now looking at operational performance. So that's where we are.
Wow. So you got to tell me, what were some of the first projects that you did coming out of college with the company that said, "I've got an idea, just make it happen"?
Yeah, well, our task was that building a linear diesel hydraulic generator. With no rotation in there, just a piston moving back and forth. And without going into details, that has great advantages for a lot of things. We suddenly realized as well that we built the loudest drum computer in the world, because you could basically put some drum sequences to it and it would follow it nicely. And that it was a lot simpler than rotating that. Combined with that, after that, and it's not my idea, but we built a hydraulic transformer, which is basically in electrics, you have transformers, so you can get the voltage up and down, all to your liking. In hydraulics, that didn't exist until now, or 10 years ago, 20 years ago. And if there's one real invention, it's that normal hydraulic motors have two openings, a suction and a discharge port. And basically the director says, "Why not add a third one?" So we had 3 ports, and then suddenly you had a transformer. So the nice thing is, with building those things, we have to do it quickly. So we actually 3D printed in metal in about 2000, 1999, we were already 3D printing engine parts and all that. So that's about, let's say, 25 years ago. So that was pretty cool to do that.
Wow. I mean, that is definitely the earliest I've heard of anybody doing, I guess, commercial or engineering practices of metal 3D printing. So you're doing AI and 3D printing early on before either one of them became mainstream.
Yeah, more or less. Yeah, that's and
I,
yeah.
oh,
Okay, go ahead, sir.
no, I was going to ask you. So, you know, now with where you're at in your position, I want to kind of do kind of a retrospect thing. How useful do you think it is to be able to allow new engineers to be able to do that same, to have that kind of same open platform, I guess, structure or mentality to allow them to be able to come in and really be able to explore different ways to solve problems without having too much, you know, without having to put them inside of a box?
I think it's worth gold. It's not for everybody. I mean, you get a task and you need to develop something or design something, and if you have to start with a white sheet of paper, the hardest thing you do is making that first line on paper and thinking, okay, this is how we're gonna progress forward. But I think the experience you gain in actually troubleshooting, in designing things, finding out how do I make this, and then later on, how do I test it, and how do I prove that what I think it is actually happening. And you suddenly realize with that reality is complex. Everything you do at the universities is easy. I mean, it's nicely controlled situations, and the formulas are easy. Once you step out of that into the real world, well, then it becomes a lot harder. And all your nice methods, yeah, they work, but it's a lot harder to get real true results out of it. So I would say it builds better engineers, it builds better employees that know also their limitations, because you have to develop yourself as an engineer, and you're in your career, you don't know what's in it for you. Where is your niche playing? Where's your area where you really can shine? And yeah, giving people that opportunity, that is literally worth gold. And also for companies, I mean, if you have employees that know what they're worth and where they can shine, and you listen to them, you build better organizations. So I can talk a lot about this, by the way.
I mean, I keep going. I'm more than happy to be able to listen. I mean, like you said, it's worth gold, and you could be mining for gold. I mean, or trying
Yeah.
to scrape it up off the seafloor bottom, like you said.
Yeah. So, but once again, it's not for everybody. I mean, it has a certain mindset. I worked almost my entire life within Huisman in the concept department, and yeah, you get affected with the mindset. How can I make things better? Everything you look at suddenly is worth improving. And some engineers like that, some of them don't. What I also can highly recommend is for people, or for especially young engineers, go to a technical library. Spend a few days there, peruse through the books, try to find something, just surprise yourself more or less with stuff you never knew existed. And just like my own journey, a lot of good stuff was done before Google. And the current engineer, sorry, but if it's not in Google, it doesn't exist anymore. And so I get a little bit sad in that aspect that universities are basically ditching a lot of the libraries and making it not very accessible to people. And I think that's the wrong way. It is there where you find a lot of stuff from the old days. And it's fun to read all the problems they had and how they fixed it.
Well, I mean, that's a great way to look at it, is that, there were a lot of good inventions before Google, uh, I guess it started putting them on the internet. So so is that something like you find ideas or references or just different ways to solve problems? Like what would be something that you would do if you went into one of these older libraries looking at technical materials and stuff?
Well, if it's a real technical problem, going into, for example, patents is always a good start. And what you then find is you find names of companies that did stuff around that area. Then you go into, if you go to a library, you have those monthly magazines. And in the early days, I mean, that monthly magazine was everything you had for showcasing your idea of transferring knowledge. And you start looking for those companies, what they did, and looking at pictures, looking at their, for example, ships, their launching ceremonies, and how they did stuff in the past. And it usually comes up with some good ideas. And you say, yeah, I didn't think about that, or hey, we can do this, or just plain saying that hey, this doesn't work, because you see the results that came out of it. Say, okay, that apparently didn't work. Let's move on. And one tidbit of information that people don't know is that how the CIA, for example, funded a lot of research that is now predominantly used in deep water. I don't know if you know that, but they did.
No.
And it is, I forgot the name of the rig, but it was from Mr. Huge. Back in the days, there was a submarine at 4,000 meters, that's 12,000 feet. And there was some secret codes, and with the cloak and dagger stuff, you want to get the codes. And so the Russians didn't know where the submarine was on the seabed. The Americans did, and they basically talked to Mr. Huge and say, "Hey, can you design a ship that can do that? Lift a few thousand tons from the seabed at 4,000 meters water depth in 1973 or 1974." And if you remember that during those days, that there was a huge uptick in manganese nodule mining at the seabed, and Mr. Huge was a big proponent of that. Well, the nodules were there. The story was completely bogus. It was made up because they needed to have a reason why they built a ship that can go down to 4,000 meters and grab a couple of thousand tons from the seabed. So they did that. They actually managed to do it. You can find it in YouTube and internet, how they did it. But for example, heave compensation, gimbaling drill floors, drill pipe design, tool joint designs, DP, underwater cameras, stuff like that. If you look at the budget they're working on, I think the CIA invested about $1 billion in today's currencies in developing those technologies.
Wow.
And so the vessel was later converted to a real drilling rig, and it has been drilling for Transocean for decades afterwards. So I always think it's a nice story. It's an unexpected result of some cloak and dagger stuff that happened, but we made good use of it afterwards.
Oh, I think here we go. John put up the information on it. I won't read all of it, but I guess if anybody wants to be able to Google it, there it is. I guess I've got some either YouTube or reading material for after the show to be able to go in and watch. So this brings up a great point as far as it's an area that you've spent a lot of your career doing R&D, research and development. What are your thoughts now on where the industry's at as far as investment in R&D? This is something that we spoke with Demetrius last week, but would love to be able to get your insights on it as well.
Well, I think one item is the role of universities and cooperation. And I can explain that in a little bit more detail. If you look at, for example, a barrel of uranium, that is a lot of money in terms of energy. You can, with a barrel of uranium, you can power a city for 20 years or something like that. I mean, it's astounding amount of energy. So if you have parties working together to get the energy out, everybody can get the fair share. And there's a lot of parties that can get their fair share because there's a lot of money in that barrel. And that's why, and they have to, of course, the nuclear power plants are basically very technology developed, and yeah, they cannot make any shortcuts, obviously, but you can invest a lot in an ecosystem of companies that revolve around that to get basically the energy out. If you go to barrel of oil, there's also a lot of money in a barrel of oil, and so you can have an ecosystem of oil companies, contractors, of operators, contractors, service companies, service companies, and stuff like that. Everybody can get their fair share of that and survive by that, because there's still a lot of energy and money in a barrel of oil. If you, for example, go to geothermal, there's not much energy in a barrel of geothermal. I mean, the energy density of geothermal is low. So that means that the whole ecosystem that goes from really big uranium and R&D that is attached to that to make that happen, all the way to geothermal, is where you cannot have a lot of parties each grabbing a part of the pie, so to say, because I mean that pie is not that large. It's it's pretty small. So I think in terms of R&D, we need R&D. I mean, it's obvious we didn't make the progress we made over the last decades and so on. I mean, fracking would have nowhere near where it's right now, or shale, if fracking was not developed and tested out. And so I think that for R&D and our current environment, we need to work together. It is absolutely needed. The industry needs to, in my view, sit together and say what are core technologies we need to drive the industry ahead. And if it cannot be done by one company, the company should be more than willing to cooperate. And for example, universities are very important with that. I mean, they can be the independent broker of knowledge. Nobody has to be worried about, hey, we're sharing confidential information or whatever it is. And I want to highlight that with one technology that is now in development, and Erik van Oort from UT is doing that, or working on it amongst other stuff, but is insulated drill pipe. You need that for geothermal, and to basically open up your normal drilling tools, your efficiencies and all that. If you insulate your drill pipe, a lot of other good stuff starts happening. But insulated drill pipe is probably something that a company cannot develop on its own right now, because the market is too small, too fragmented and all that. So that would be something where universities or GIPs can play a really big role in driving the industry forward. But if you see what kind of gains we have made in the industry, I just read a book yesterday about the Russian developments in the oil industry. Yeah, you wouldn't think of it, but they do. And they were reporting in the 60s, they were drilling 2,000 meters a month. We're now drilling 2,000 meters in a day or something like that. I mean, it's pretty fast what we're doing. So you can see the progress we made, a 30-fold increase of speeds and efficiencies. And I think, basically our clients are expecting from us that we keep on basically improving on those numbers.
What do you think are some of the other core technologies that the industry should focus on?
Not AI. I mean, it's a contrarian. Yes, no. Because AI is a derivative. And in my view, and people might disagree with that, AI is not knowledge. AI is just a bunch of numbers. AI will never be able to design something to make the next step. Sorry, it's not going to happen. AI is good in improving processes we know and making incremental gains. But for example, if you have insulated drill pipe, well, you need to do your formulas. I mean, you need to start looking at material combinations and things like that. Well, afterwards, you can use, if you want to, AI for basically optimizing that and say, hey, just go on the Google net and see if there's a better material available or things like that, or maybe a different combination. But so I think a lot of research or development, I think, needs to be the next phase of robotic drill floors. Because if you look at it from an historical perspective, is that we're working with drill floors that were designed in 2010-ish, around that date. If we talk about the offshore world, that is. And right now, people are trying to get robotics or automation or autonomous operations. I mean, there's different words, and most of the times they mean people think they're saying that they're not. But is what I see now is that we're using robots to replace humans. And that's a lofty goal. I mean, you mentioned with the start of it, say, hey, you're on the drill floor, you shouldn't be there. Well, yeah, that's true. Absolutely correct. Can we use robots for that? Yes. Can they be successful? Yes. Is it the best way we can do it? I don't think so. If you design a drill floor from the ground up and then saying we have all these new cool toys, all this automation and whatnot, and maybe we have to design a new type of drill pipe joint connection or something else that is targeted for automated operations, and I think we can get a lot more value out of it in that sense. Bit of a long-winded answer. I mean, it's also R&D. You never know where you're going to get in the end.
Well, it makes me think of, I had a friend tell me one time, it's like you don't want to design a robot to tie your shoelaces. You want a robot that just folds over the Velcro flap on your shoes, right?
Exactly.
So you achieve the same thing, but which is fastening your shoe, right?
Yeah.
But one process is what we're completely used to, whereas the other process is slightly different, but way more simplistic. So, saying that, what kind of legacy things are we looking at as far as with the drill floor that really could be, if we just started from, like you said earlier, a blank sheet of paper, were to put the first line down, how could we reimagine the drill floor and build it up in such a way that, all of the new technology, drilling automation, some of these other technologies that are out there could actually make it a more efficient and simplistic process?
That's a good question. I don't know.
Fair enough.
Fair enough. But what I can say is that if you look at the more human aspect, and I think that's low hanging fruit, to be honest. If we're going to talk about big mechanical stuff, there's a lot of cost involved in that and a lot of risk to make that work, of course. But if you look at the driller's cabin, I mean, the drillers are almost 100% overloaded with information all the time. And they might lounge in the driller's chair. They might do is like looking cool and saying, yeah, we're in control. But the point being is that a human has a certain limit in bits per second that they can process. And that's a hard limit. And some of them are better, some of them are worse. But if you look at the driller's cabin, they overload the drillers with information 10 times. So in my view, we need to get, and that's not new, of course, but we now have the tools to actually do it, is we need to decrease the number of screens in the driller's cabin. We need only to show situational awareness enhancing information. So the drillers need to be shown only information that he needs for his job at that particular moment in time, nothing else. And I think we can make great strides with that, and also by getting the drillers more in a process operating mode, where they're more like process operators. A very old story. We have been talking about that for at least 10 years. Those numbers, and I would also basically give a warning. Basically, if you're programming, for example, you should not programming to the top of your abilities. If you make a program that is the best you can do, you can never troubleshoot it, because troubleshooting is the next higher level. So if you want to write a good program, do one step back, so at least yourself are capable of actually troubleshooting it, because that is a lot more difficult. What we're now getting is a lot of complexity on the rigs, and in terms of automation, PLCs, signals, etc. And I think we have to be wary of the fact that for contractors, our job is to drill a hole, and our job is not to troubleshoot PLCs and everything. That's just waste. Sorry. So we have to carefully balance bringing complexity on the rigs with actually what we're supposed to be doing, in a sense, and how much manpower is in that sense dedicated to that process of keeping the rigs running. We do a good job. I don't think people know that, and I always find it good to reiterate that is our systems are basically running 24/7 for the last decade. They hardly, some of them have never been switched off. For 10 years, they're running all the time. And try that with your phone or your computer or things like that. So, yeah, the people who designed it in 1986, 1990, because that's where a lot of work comes from, they did a fairly good job, I must say.
Good kudos to those guys. But yeah, it's a very interesting statement to say that we've got equipment out there that hasn't been shut off in 10 years. I can't think of anything that's even in my office that
Nope.
It's like shoes, t-shirt, jeans, nothing. My glasses, right? Like nothing's lasting that long and being put through that amount of work. So it's a very impressive thing to be able to think about. Before we get too further off, Mr. John DeWart's got an amazing question here. Robert, do you see the uptake of automation on offshore rigs leading to a significant concept change for offshore rigs?
That's a good question. I think in the short term, no. And the reason being, and that's what's nice that I have the background in there, is if we make a big change on the drill floor, that probably will require a change in equipment. And that means that there's a lot of capital expenditures attached to that. We're not going to change out the top drive just because the new one is AI powered or whatever it is, just because we have to justify the cost. And the top drives we're using right now are really good, and they do what they need to do. So on the short term, I think there is a hard wall of, hey, you have to be able to justify the cost in terms of what automation will bring. And kudos to our crews. They are really efficient in what they're doing at this moment already. If you look at a longer period of time, in my personal belief is that we probably have an opportunity there where we basically are, because the lifetime of the drilling equipment on the drill floor is not infinitive. I mean, it functions fine and this and that, but there will be a moment in time where you say the maintenance and downtime is increasing now exponentially. We either have to replace the whole thing or do something else. Well, if you do that, then there's certainly an opportunity saying, okay, if we have to replace it or spend significant funds to get the next 20 years of life out of it, why not look at something that is maybe entirely different from a constructional purpose, but does the same function? And like I said, it's not on the horizon right now because, as we all know, we are still in a bit of oversupplied situation where we have to be really careful in terms of where we spend our money and get our worth out of it. But I do think there will be in the medium term opportunities, basically to look at somewhat radically more different drill floor designs and automation concepts.
So one of the things I want to ask you there then is with the drill floor automation and the progress that we've made offshore, do you see that technology bleeding over even more into land-based drilling operations?
Well, it might come as a surprise, but I think offshore is behind onshore. So we have to look at onshore to see what's going to happen offshore. And the reason for that is very simple. And actually, the shale is something that it's a Darwinian environment because the drilling there is cutthroat, as you probably know better than I do. I mean, every penny counts, every measure of efficiency counts because you're drilling a lot of wells. In my view, is that because you're drilling a lot of wells that are per well not that expensive, you can try out a lot of different ideas. If it doesn't work, you have one well to deal with. If it does work, you can certainly spread it out. Combined with the fact that onshore, there are parties like Neighbors and H&P and Ensign that actually own their own drilling rigs. And in a sense that they also own the automation systems. They develop that stuff themselves for a part. I mean, they also use others. That means that they are a lot more in control of what's happening, and they're a lot more incentivized to basically roll improvements out because it's their core business anyway. Offshore is different. There is I don't know if there's anyone out there, a drilling contractor offshore that develop their own control systems and build their own rigs with, for example, the Noble drilling control system on it. And we have a big department managing that and this and that. It's not happening. We are a lot more dependent on OEMs. And also the stakes are a lot higher. If something is introduced and it doesn't work, offshore wells are pretty expensive. So
yeah, just a little bit.
Yeah, just a little bit compared to the onshore. So long story short, I see a lot more innovation and incremental improvements going on onshore that offshore, I think, needs to have a close look at and say, hey, what those guys are doing, can we mimic that in the offshore environment? And so because we already know what doesn't work, so we only have to cherry pick the stuff that does work and is transferable to our world. I think MPD is one of those things that made inroads onshore and then finally made their way to great success, I must say, offshore.
Wow. It's definitely a fascinating perspective to be able to hear that, because I was thinking it was going to go quite the opposite direction. So we've got a question here in the comments, but I want to ask you one more and we'll jump over to it. In the offshore environment, have y'all seen the drastic increase in drilling rig efficiency, similar to what we have seen in U.S. land. For example, 10 years ago, one rig in U.S. land was doing about 10,000 feet a month, and now we're at about 37,000 feet a month per rig. Have y'all seen some of the big drilling efficiency increases offshore as well?
Yes is yes. With a caveat to it, you see that where in the case of Noble, where we have a client that really wants to go for the win-win and is there for a longer duration of time, because it's incremental gains. So we are drilling for Exxon in Guyana, and we have a pretty large operation going on there. And Exxon is a client of us that is very focused on improving the drilling process there and is willing to work with Noble to make that happen. And ideas come from Noble, ideas come from our client Exxon in this case. And what you see there is really something that is lifting off right now. If I look at our drilling performance there, it is off the charts. It is really, really good. But it was not done by a silver or golden bullet. That drilling performance was carefully basically made better and better and better incrementally with small little things that counted. And like it's, for example, Noble is looking really detailed into their operations. We call it nano KPIs, really looking at making sure that the crews follows best examples to the tiniest details. And what you see there is that by having that long-term relationship, by having a focus of both parties on improving that and listening to each other, I mean, small increments, just like an interest rate, small things every day add up in the end to really significant gains. And I think that is something that the offshore industry can take it hard and say, listen, if we want to really improve our performance, we cannot do it on our own. The drilling contractors cannot do it. The operators cannot do it. It's really the cooperation between the two that makes that happen. And there is no golden or silver bullets. Those don't exist. Because quite honestly, just onshore, I mean, kudos once again for our crews. They do a really good job in terms of efficient operations on board. It is really difficult to find, from that perspective, meaningful improvements in what they're doing. And onshore, the same deal. I mean, I don't think there's really bad crews out there. There's good crews and there's really good crews. And because bad crews, they've been long gone. I mean, it's not an environment that tolerates that.
I really like that. That's a great statement. All right, so before I forget, we're going to jump over to hear some of the questions. So, Robert, for those who missed the IADC discussion 2 weeks ago, could you briefly explain the role of interoperability in automation?
Okay, well, here we go.
Buckle up.
Buckle up. Yeah. So, interoperability in operation. I mean, then you have to look at what kind of value does technology bring to you. And I showed that chart with a nice little pyramid in there, the drilling rig at the top and a drill bit at the bottom. And I said, listen, first you have to state your goal. I mean, if you don't state your goal, then you have no meaningful discussion. So if your goal is drill the hole in the shortest amount of time to an acceptable quality, then you can start defining what contributes to that goal and what does not. And so what contributes to the goal, for example, is drill bit design. I mean, a 5% better drill bit, drilling 5% faster, is directly 5% making more hole. Done. A one-to-one relationship. And then you have, for example, a middle layer that says, and that's where the drilling contractors come in. It's basically saying, we want the rig spinning at bottom the majority of the time. Every second the drilling bit is not doing that is waste. We have to avoid that. So tripping speeds come in, casing running, cementing, bit runs. We have to do it as efficiently as we can. And then we have the top layer. And the top layer basically is minimizing waste. And the safety, for example, is in the top layer. The characteristic of the top layer is you do a stellar job. You do 100% no incidents, no accidents, and you won't drill a feet per minute faster. You just don't. Crew is timely fed, is ultra happy, you won't drill faster. However, if you don't do a good job in the top layer, then the goal is affected. So you do a stellar job, nobody will notice, and basically you make a little mistake and everybody starts screaming. And interoperability basically connects the layers. Because if you have, for example, a program that basically is weight on bit optimization, it does require information from the second layer, our rigs and all that. Interoperability makes it happen that the program you can ask a lot of money for, weight on bit optimizations or whatever it is, with something that it needs from other layers. And the same with the top layer, all the information and all that. So interoperability is making sure that you can make good business cases all across the layers. Because if you only focus on the top layer, then your business case in that layer is tough, because we're already doing a stellar job. We're already doing it pretty good in terms of logistics and all that. And you want to improve that? Well, that's nice, but it doesn't add to your bottom goal of making whole. However, if you can make sure that that top layer is suddenly connected with your bottom layer, then you have a very different discussion. Long story. I told you so.
It's quite all right. That's what the show's here for. So this was a long one, and it's a fairly quick. But how do we keep adding automation processes without overloading the drillers? There are drilling cabins with more than 10 screens for the driller to interact with. Each new automation piece seems to increase the number of screens. So I'll stop it there because I actually think it goes a little bit longer, but because of the size of the comment, not all of it can be put in there. But I would like for you to be able to put your thoughts on that.
Well, it's very simple. Stop being affected by nice, colorful screens and making decisions about how many colors you can show. And listen to the drillers. It is very simple. And you have to be brutally honest in terms of who is your client. And if the driller is your client, he needs 5 numbers. That's all he can do. He can rotate. He can have weight on bit. You have some fluid pressures with NPD. You have some mud properties and RPM and all that kind of good stuff. So 5 numbers. That's all you need to show. And everything else should basically something that is actionable for him. You have to give him information so he can change one of those 5 numbers, if we're talking about drilling. Everything else he doesn't need. He cannot make it. He can make a decision. He cannot act on it. So, but people love the squiggly lines and all that. So, including myself, it's great. You have a great screen with all the squiggly lines. But if you ask the question and saying, listen, what kind of decisions is this making? Well, what helps the driller in making decisions? Does this help the driller making a decision? If the answer is maybe or no, forget about it. Do it somewhere else. And I mean, I'm guilty of that too. I mean, screens full of color with squiggly lines, great. I mean, they look good, and it's nice, just nice. But I think we have to really put the end users front and center, and saying and ask them, what do you need? And for a driller, it's simple. And then you have a maintenance guy, he needs entirely different numbers. And then you have guys in management, they need different numbers. And I also think that we, as an engineer, I want to have all my information at my fingertips. I will figure it out what I need. But driller screens should not be engineering screens. They should be operational screens. And if you look at that in terms of airplanes, the reason why they can fly an airplane with 2 persons instead of 4 or 3 right now is they have adaptive screens. The screens present what you need as a pilot at that given moment in time. That was not the case way back when you had the manual dials. So you need another guy to watch those dials for the event that something was happening or for his particular thing. So I think that is something where we can make great strides. I have yet to see a driller's cabin with screens that are adaptive. They're reacting on the situation at hand. Example, if you have a well control situation, everything should be blanked out except what you need to get the well back under control. You need your BOP information, you need your fluid, you need your ECD, you need your kill sheet, and you need to it's nice if you have already a set of actions to be taken that are predefined. He doesn't need HPU temperatures. He doesn't need position of pipe wreckers or basically the setback, how many pipe is there in the setback and things like that. That's irrelevant for that situation. So once again, a long story, but I get a little bit passionate about that because I see very little movement in terms of that. Getting the driller first and center and ask him what he needs. And don't get me wrong. I mean, the stuff that's being developed now by universities and little startup companies, absolutely stunning what they can do. But very little that I see is that, listen, talk to the driller. Does he need your screen or does he just need your decision? And that's a fair question. I think you can ask them and say, hey, I like what you do on the background, but we don't need all your intermediate graphs and all that. That's irrelevant.
I think that's an amazing point. And hopefully there's some other entrepreneurs watching this, because for me, like, hearing this is just like, well, let's do that exact thing. Let's design that exact route. So it's very interesting to hear. It's funny enough. John says geos need different numbers. Yeah. So everybody out there is going to need something a little bit different. Brian said red light, yellow light, green light, and we used purple for imminent failure. And then John says, I get dashboard tons of data and can customize my screens and curves to what I want to see. So I think it's maybe
that happens a lot with MPD guys, for example. And you can basically save your user screens. And the guys made it pretty clear that nobody touches their personal settings. They were very clear about that.
Don't mess with how I have my chair set up.
Exactly, and colors and stuff like that.
Well, Robert, thank you so much. Is there anything else that you would like to be able to be able to share with the industry and for all of those that are out there watching?
I want to actually 2 things. One of them is go to universities, get interns, go to elementary, middle, high schools, and get the younger generation in. Basically, we need to open up our doors. We need to open up our usual secrecy of hey, we're doing a good job, but you're not allowed on the work site. We at Noble managed to get students on a drilling rig that's floating across the coast. It was warm stacked. I think it's key for the future of our industry that we get the younger generation interested in a career at our industry. In what shape or form, it doesn't matter. The only way to do that, to get the real good, motivated people, is to open up and say, hey, come visit our drilling rig. We have every Thursday on a land rig, there is an hour spent that you get people in, whatever the case may be. We need different people. We need workers, we need office people, we need smart people. But if we don't open up the doors and open up, they will not come. And I think that is, and give talks at the university. I mean, it is amazing what I see, the level of energy that those young people have and are willing to put into a cause they believe is beneficial for them. And if we can align those two, what's beneficial for us and beneficial for them, then we have a real win-win situation. So that is something that I want to make that point for the industry is listen, I mean, we need the young people and we need to start opening up. It's not difficult. I mean, the worst you can do is have a question like we had on the rig. People were utterly amazed. Says, don't you feed people with frozen pizzas and canned food every day? I said, no. They were so amazed. We had a full galley of food with all the choices. I said, you want to have a mutiny on board? Come with bad food. It will last about a day, less than a day, and then you will have a. So those kind of misconceptions is very easily to take away. And the other thing is collaboration. I cannot stress enough that the world we live in right now is actually forcing us, I think, the industry to collaborate on things that drive the industry forward. I'm not saying we cannot compete, but I think there is at this moment a gap in what individual companies can spend on R&D and technologies that need to be developed. And if we can bridge that gap by just cooperating with each other, why not? I mean, it's better for everybody.
Well, Robert, thank you so much for coming on to the show today. I'm excited to hear that the rig crews are not just being fed frozen pizzas and canned food. It's been a long time since I've been offshore, and I'm happy to hear that there's still good food and plenty of weight to be gained offshore.
Oh yes, it's tempting.
All right, guys. Well, Robert, like I said, thank you so much for being on the show. We'll do our quick little giveaway here in just a second. So if you have not already, I don't want to drop this thing. Be sure to put in hashtag rig reports. I do want to call it. So Brian says, love that. Is the screen needed or is the decision needed? Collaboration and clarity is in consistency. Some great feedback there from the show today. And let me go ahead and get this pulled up. Share screen. Entire screen. Chrome tab. There we go. Uh-oh. Oh. I made a mistake. I forgot to hit the thing. So there's only one entry, and it looks like it's John. Well, now there's two. So it's between Eric Allen and Sean. I am so sorry for everybody else that put that in today. I forgot to finish doing my job. But there we go. Eric Allen, you're the winner. It was a 50-50 shot. I apologize, guys. Wow, I'm going to have to make that up to everybody on the next show. Speaking of which, next show, nothing next week. I'll be at the ISCWSA meeting in Norway as well as the SPE conference. March 14th, though, Eric Caillou, head of Norse Drilling, will be on the show March 14th. So So we got lots of comments there in the comments. Sorry, guys, I completely messed that up. Yep, I have to be better, right? So there was my technical mess up for the day. Once again, though, Robert, thank you so much for being on the show. Thanks everybody for watching. Look forward to see you guys in 2 weeks. And as always, that's it for me, guys. Know your industry.